Welcome back. I'm René. I work for Bridge Diagnostics in Boulder, Colorado. In this session, we're going to set up event recording. Before we start, we have to see what we are going to record. Let's go back to our standard STS live mode of operation, and we start a recording. Enable the sensors. And we want to record events when they happen. And this is an event I would like to record. You see the signals are passing over a certain level. And I want to record what happens when that event happens and what happens afterwards. So let's stop this test and have a look. We can activate the cursor, select it on the sensor, and move the cursor around. And you see here, these sensors are going negative. Let's say that if we pass -10 micro-E on this sensor, number 4, we want to record an event. I just wrote that down. Let's go into the editor, open the editor, and let's delete the previous exercise. Ctrl-Shift, click, erase it. Add the type of test, event recording, and go into the editor. Event demo. Now let's double click on the event demo and we see the parameters needed to tell the core what to do in the case of event recording. We have different modes. We're going to use the most common mode, which is the pre-trigger mode. If you're familiar with triggering, it basically works the same as on digital oscilloscopes. Just as a reminder, if we have a signal that goes positive here and passes a certain threshold that we can adjust, we want to call that an event and want to record what happened. We want to record what happened before it happened, and we want to record what happens after. To do that, we have to specify this area. We have to specify that duration, and we have to specify what happens after the post-duration. Let's see. We have pre-trigger mode, pre-trigger time. Well, for the demo, we're not going to wait 3 minutes. We're going to set it up very short. We're going to use 5 seconds. And the post-trigger time can also be very short. We do about 10 seconds. The pre-trigger valid time is a noise filter. It basically tells the system to ignore an event that was so short, it did pass the threshold, but it was too short. If it is shorter than 0.2 seconds, we will ignore it. If it's longer than 0.2 seconds, the trigger is valid and the event will be recorded. All left is to select which channels are going to be used. We can select multiple channels and we can combine the channels using an OR function, meaning that any sensor that passes the threshold will start the event recording. Or we select the AND function, meaning that all sensors need to pass that threshold. Most commonly, we use the OR function. That adds the sensors. And here we see the 3 sensors with their parameters. The parameters tell you that the trigger polarity is off, meaning that this sensor is not used to generate an event. We simply record this sensor when an event happens. We need to tell the system to look at these sensors. So let's double click on the sensor and tell the system to use it for trigger. The polarity is positive, but we saw previously that we want to trigger at -10 micro-E. So we have a negative setting here and a pre-trigger level of -10, meaning The signal, if it is going negative, it has to have a negative slope, and it passes -10, the system will trigger. We do not need the post-trigger level. I will come back to the auto zero settings. We can save this. And now we are basically done for this simple test. We have one channel where the system will trigger, and we have two channels where the data will be recorded, but these channels will not cause by itself an event. Let's go out here, and the system has sent it to the core, so we're ready to start testing. Let's start. And here we see that I made a mistake. Let's stop. We have to put the system in monitoring. I go back to our setting page. We're all good. And let's try again. Now we see that we have the right sensors. They're called event demo, and we will have to activate these sensors. My system is very slow. Nothing will happen until an event happens. So let me generate the event. And you see it's recording. It immediately started with a large chunk of data when I passed the threshold. And we can see that at 5 seconds, I passed the threshold of -10. That is exactly what we wanted to do. And it recorded after this 10 seconds of data. Let's see what the system saved to file. Here we see the event demo test. We can open that. Let's plot the data. And here we have the data recorded. You see that in the recording, it actually has the time 0 at the trigger event. We do not save that, don't save, and we go back to our settings. Let's make the system a little bit more complicated. We go back to the settings page, we go back into the editor, we go back. A notorious problem we have with sensors is that sensors can drift away. Especially strain gauges can drift away more than your trigger level can handle. For that we have the auto zero mode, meaning that we will dynamically zero the sensor during data acquisition. The event specification is from the 0 level. So we're going to auto zero the sensor, and we have to select that mode. It's an average mode, and we have to give it a time constant. The time constant is a digital filter. Let's give that a time constant of 500. What does that mean? Here we have, fortunately, a help button here. We have simulated data, and the data shows you the original trace, what I call raw data, it's the blue trace, and we have the compensated data, the red trace. You see we have an event, but the event is too small to find in the trigger setup, and then here we have the data recorded. We can do a dynamic offset, much of a compensation of this signal. And let's say that we are going to compensate it with 500 units cycles are counted over the mean, and our sample rate, we have a large cycle count because we have a vibrating system. The effect of this can be seen on the red trace. Thank you for your attention. There is still a trend from whatever that cycle was, but you can see now that the original data is around 0, and we can do an event recording on it. We can make it somewhat more aggressive, Let's go to 1000 units per hour, and you see that the trace flattens out. Please note that they use different scales here. We have the raw data on the left side and the scale for the red data on the right side. So you can see that we reduce now the thermal drift, which was plus or minus 10. We reduce that over time to about half a micro E. And now we can reliably find this trigger level. To get these parameters right, you can use simulated data, but you can also load from file a TDMS file previously recorded and process that file. My setup is not usable for this exercise, so we will have to leave it here. You see the additional information is added in the description of the file. We can close it, and that is it for today.